All right, welcome to my decomposition group. So we are going to be talking about how to write decomposition reactions alone. I apologize for my voice. My allergies are at full swing, so my voice is going to be a little bit more gravelly than usual. Sorry. So you just learned how to write balanced equations for all of the different types of reactions. Now, for you, we're just going to focus on decomposition reaction because that is the type of lab report that you are going to write at the end of this. So you're going to get really, really good at writing decomposition reactions. So first, let's talk about our format equation. Like in math, when you have a formula, you replace the numbers for letters. You can add any number you want there. Well, in chemistry, instead of replacing numbers, we are replacing those chemical symbols for our elements when we write out our format equations. So, if you remember back to page 100, we had AX. This is our compound. And because we're on a decomposition reaction, that means to break apart. We're going to break apart a more complex compound into its smaller parts. So then we have A plus X. So decomposition reaction is the exact opposite of a synthesis reaction. In decomposition, you're breaking things apart, whereas in a synthesis reaction, you're putting things together. So we're going to start decomposition. We're going to start with a more complex compound, and we're going to break it apart into smaller parts, whether that be an element or just a smaller compound. So let's do a couple together. Remember, we have a couple different steps that we go through. So I'm going to write my first step in orange. So I'm going to write out all of my symbols and my charges with my arrows and my addition signs. Then I'm going to write my second step in pink. This is adding all of my subscripts in. I'm going to write my last overall step in blue, so it looks nice and clean. All right, so let's talk about our first one. We're going to do two together, and then I'm going to leave you to do the rest on your own. So we have magnesium oxide. I'm going to underline that because I know that's what we need. That's our first compound. Produces, that means an arrow, right? Magnesium, and means a plus, oxygen. All right, so you're going to need out your chemical formula sheet. So it's really important that you have this, otherwise it's going to be a lot more difficult for you. So, magnesium, Mg2+, oxide, O2-, it's going to produce, that arrow, Mg2+ plus O minus 2. If you say minus 2 plus 2, 2 minus 2 plus, same concept. I should try to stay more consistent though. I will do that in the next problem. All right, so I have all my elements accounted for, all my compounds accounted for, my arrows and my addition signs, so we're ready to move on to the next step. So let's start with our compound. So we need to have a balanced compound. So if you go back to your steps for writing an ionic formula, remember if we have equal but opposite charges, they cancel out and we're left with just MgO. Mg, I don't see it attached to a compound, so it does not receive a charge. Our only other thing we need to check for is it on the diatomic list, bottom left-hand corner of your chemical formula sheet. I do not see it, so he's just going to stay all by himself. Good to go. Oxygen. Since that's all by itself, let's check our diatomic elements. There's oxygen. Oxygen should have an O2. So that is a diatomic, meaning that when it is out in nature, it exists in pairs. So we will always put it in our formula as a pair. But that's only if it's by itself. It's only if it's an element. If it's in a compound, that rule does not exist. So with decomposition reactions, since you will only be writing decomposition reactions, your diatomic should only be on your product side. Should only be on product side. This other O depends on the charge of the magnesium as to how many there needs to be in that compound. Okay, so we've got our subscripts in. Now let's write out our chemical equation, and we're going to leave space for our coefficients. So space for my MgO is going to produce Mg, that's an element, so no charge. O2, because that's our diatomic, but it's also an element, so no charge. By the blue step, you should never write charges. We take care of that in our pink step. All right, I'm going to switch one more time to pencil so I can balance this out and not mess up and have to like scribble things out. All right, so I have one Mg on both sides. I have one O over here and two O's over here. All right, Mg, Mg, those are balanced. Oh, well, there's two O's. All right, what do? I bring the bigger number over. Divide. 2 divided by 1 is 2. All right, let's check to make sure I did all my math. 2 times 1 is 2. 2 times 1 is 2. 1 times 1 is 1. 1 times 2 is 2. All right, so I have 2 magnesium. Oh, I only have 1 over here. Okay, we want 2. Put that 2 there. 2 divided by 1 is 2. So I have 2 magnesiums, 2 oxygens, and I am good and balanced. So that is our final form. We're all set to go. Now remember, the balancing step is a material. If you are happy with a B, you're good to go. You can leave it as just this without our coefficients, and that is a B. But as I think all of you are very smart and very capable, I would recommend pushing yourself to get that A, to balance them, because I've seen your balancing work and you're very capable to do that. All right, we're going to do one more together before you do the worksheet by yourself, and we're going to do number 8 because it has you come up with the products, and you can do that. All right, we start with our orange using the chemical formula sheet. So we got chromium 3 fluoride, and that's all they give us. All right, here we go. Let's write it out. Chromium 3 is Cr plus 3. Fluoride is F minus 1. And we know because of our format equation, and we're going to have AX, that's our chromium 3 fluoride, is going to produce A plus X, okay? So we need to produce, meaning an arrow, A chromium plus F minus 1, right? This is our A, this is our X. We're splitting this apart. It's a decomposition. Okay. Let's switch colors because we have everything written out with our charges, our arrows, and our pluses. So let's start with this. 3 and 1, is that equal but opposite? Nope. So what do I have to do? I gotta crisscross. So I've got a 1 here, a 3 here. So chromium 1, F3. Chromium is all by himself. Is he on my diatomics elements? No. So we're just gonna cross off the charge. Fluorine is on my diatomics elements, so that becomes an F2. Okay. I've got all my subscripts in. My compound does not need a parentheses. So let's write it out with space to balance. Cr1F3 is going to produce Cr plus F2. Okay. Got 1 Cr, 1 Cr. Ooh, and I messed up. I'm not supposed to write my 1. Remember, those 1s are implied, so I messed up. Okay, so I have 1 Cr, 1 Cr, 3 Fs here, only 2 here. All right, what do? We bring the bigger number over. 3 divided by 2 gives me, ooh, like 1.5. That doesn't work. What do we do when those don't work? We multiply. 3 times 2 is 6, so now I want 6. And then we divide. 6 divided by 2 is 3. So if I had 6 F's over here, I want 6 over here. 6 divided by 3 is 2. Let's check to make sure we did all our math. 2 times 1 is 2. 2 times 3 is 6. 1 times 1 is 1. 3 times 2 is 6. All right, I've got 2 chromiums. I only have 1 here. Okay, so now bring the bigger number over and divide. 2 divided by 1 is 2. So 2 and 2, 6 and 6. Am I good to go? I'm good to go. This is our balanced equation. All right, so now that we wrote out our balanced equation, we are done. I want you to try the rest of them. Be careful on number 9 and 10. Those are challenges. I know you can do them. Just like take an extra minute to think about it and how to write those. All right, and then don't forget your reflection down at the bottom. Good for you to think about what you were doing and if it's easy or hard. So if you are virtual or in person, please don't hesitate to reach out and talk to me about any questions you have, any concerns. Just let me know. All right, have fun writing out your decomposition reactions.